In example 6, we want to find the general solution to the differential equation listed at the right-hand side. The very first thing we need to do is to separate our variables, but even before that, we have a little issue to take care of on the right-hand side. I don't know if you noticed it, but there's a y squared here in this term, and then there's a y squared here in this term. Remember, terms are separated by plus or minus signs. The very first thing I need to do here is I need to actually factor that y squared out. I want to get y squared times something in terms of x. And so if I can have y squared times 1 minus sine of x, that's actually going to work out well for us. Now we can go about separating the variables. So I'll multiply each side by dx. And then I'll also divide each side by y squared. So the y squared will be down here in the bottom. When I do that, the dx's cancel on the left, the y squareds cancel on the right. And I wind up with 1 over y squared, or y to the negative 2 power dy. And you can represent that as either y to the negative 2 or 1 over y squared. For us to use the power rule in reverse, which is going to happen next, we're probably going to want to list this as y to the negative 2. That's equal to 1 minus the sine of x dx. Now that we've separated our variables, we're going to integrate each side, or take the integral of each side. If I work with my y to the negative 2, to use the power rule in reverse, I need to add 1 to negative 2. So negative 2 plus 1 is negative 1, and then divide by that new exponent. On the right-hand side, I need to integrate 1 minus sine of x, and we're going to focus on each term. The first term is 1, and so the antiderivative of 1 is just x. And then we're going to focus on the negative sine of x, and the antiderivative of negative sine of x is positive cosine of x. In my head right now, what I'm doing actually is I'm finding the derivative of what I wrote down, and hopefully I wind back up with my 1 minus sine x. So I'll underline that for you because you can't see what's going on in my head. And if you can, that's a little crazy, but okay. So we've got the x plus the cosine of x right here. And if I take the derivative of this, I should wind up right back with 1 minus the sine of x. So the derivative of x, that is 1, and the derivative of cosine is negative sine. So I'm good to go there. That's just a step that I always do in my head, even though I sometimes don't write that down, just to make sure that I found that correct antiderivative. And I've actually forgotten one thing here that's totally necessary, and that's your plus c. Make sure that you're adding that plus c in there. To solve this one, you can go about this in a few different ways. First of all, this happens to be a negative 1 over y. If we take this y to the negative 1 and move that down to the bottom of the fraction. So that'll be equal to x plus cosine x plus c. I'm going to put that over 1. And what we're going to do here is we're just going to flip each side. I'd rather have y on the top here. I actually need to get that for solve for the general solution here. So what I'll do now is I'll write negative y. That's the reciprocal of negative 1 over y. And then on the right-hand side, I'll just write the reciprocal of x plus cosine x plus c over 1, which is 1 over x plus cosine x plus c. You could also multiply by negative y on each side and then divide by x plus cosine x plus c, and you're going to wind up with the exact same spot. Now what I'll do is I'll multiply each side by negative 1. So that becomes a positive, and then I'll put the negative 1 right up here at the top. And you can also sneak that on the left-hand side of the horizontal fraction bar right here. That's a fine way of doing it, as long as you just have one of those negative signs. So you could actually write it like this too. Some people will like writing it just like this here. We've successfully solved for y, and we have an expression on the right-hand side. So we have an equation in terms of y, which is what we're supposed to do when we find that general solution to a differential equation.